Welcome back, little tamales. Today we are going to talk about natural logarithms. This should be pretty easy. I think today's going to be a nice, simple day for you. It's going to be a lot of what you did yesterday, or I don't know, maybe not, because you can watch videos whenever you want. But it's going to be more of what was in the last video. Okay. So we're going to talk about these things called natural words are tough. Natural logarithms today. But they're just like logarithms with a special base. They're not anything new or different. Just, some special numbers. So let's talk about that special number first. We are going to talk about one of the most important numbers in all of math. And that number is E. This is the like fancy name for this is Euler's number. Whoops, number doesn't start with an M. Euler's number. And you're gonna say, Mr. Brown, that's Euler, Euler's number. It's Euler, like Euler, right? This guy was a mathematician. His name is Leonard Euler. He was like French, or I don't know. I don't remember what nationality he was, but he's the guy that came up with a whole bunch of stuff in math. So he got a number named after him, and it's E. So E is kind of like pi. It's an irrational number, so it's a never-ending decimal. It's called Euler's number. Yeah, I just told you about this. Since E is irrational, you can't write down the whole thing. The same way pi is 3.14, E is 2.718. It's not actually this, it keeps going, but that's the first three, and that's usually good enough to get us most answers. But yeah. Cool. Yeah, I don't know. It's a number. It does some stuff. It's used mostly for exponentials, which we'll do in a day or two for you. But we're not going to worry too much about what it is, right? Just, it's a number. There's a button on your calculator. Use it. All right. Let's go look at some stuff. So a natural log is what we're going to talk about today. So you'll remember from last lesson that if you see just log with no base, the invisible base is a 10. There is another similar log where they won't write the base, but it's implied. So if the base is Euler's number E, this is a natural log. And instead of just writing log, because this is for 10, we use ln for like log natural. It's the L and the N together. So ln x. If you see ln without a base, or even there will never be a base for ln. Because it's ln, it is log base E. These are the same thing. Okay. And that's all you need off this this slide. So let's practice rewriting some logs the same way we did in the last lesson. And then we'll practice using our calculators a little bit. So just remembering really quick, if we have a base to some exponent equals y, we can rewrite this as a log as log base b. The argument is y, and it equals whatever the exponent was. So if I rewrite this, it would be log base is this, so e. The thing that goes inside is whatever the exponential is equal to. So in this case, it would be 7 equals the exponent, x. Because we have log base e, they don't want you to leave it like this. They want you to rewrite it with the natural log. So we could simplify this a little bit by writing ln of 7, or natural log of 7, equals x. Let's do a couple more just for practice. So this would be log, the base is e, of the answer is 29, equals the exponent. So the whole exponent is x minus 7. And then, of course, we write the log with base e as a natural log. So our answer, just rewriting it, would be ln of 29 equals x minus 7. And they're not asking you to solve these yet. They're just asking you to rewrite them. Two more. We have, can I skip straight to the natural log? It would be log base e. So it would be the natural log of negative 5 equals the exponent, which is 3x. Same thing here. Natural log, because our base is e, of 52 equals 2x plus 3. And there we go. You're done rewriting. Pretty easy. All right, now we're going to go the other direction. We're going to rewrite these as exponentials. We're going to go from logarithms to exponentials now. So all these are natural logs, which means they have a base of e on all of them. So we're going to have e, the exponent in the exponential equation is whatever the log is equal to. So 5 equals the argument of the logarithm. So x. Couple more. E to the power of whatever the answer is, whatever the log equals the argument of the logarithm, x plus 3. E to the power of 9 equals whatever the argument is, 1/2 x. E to the power of whatever the logarithm is equal to equals the argument 2x minus 5. And there you go. You're a master of rewriting. Perfect. You did it. All right. Let's talk about evaluating E. On your calculator, you're going to see, if you have the Casio one, these are the ones that we have at school. I'm not sure if you have these or not, but what you're looking for to evaluate E is you're looking for this E to the X thing. Because it's a little thing raised up, it's not on the button itself. It's a little piece of yellow written above the button. What you're going to have to do is there's a button that is this color. On the Casio, it's yellow, and it says shift. On the TIs, the Texas Instruments, you can see it's also raised above the button, and this one's blue. So you're looking for this like this bluish color. I don't know if this one says shift or if it says second, maybe like that. It's one of those. You're gonna have to press the shift button, then the natural log button, and it'll give you an e to the x. Same thing with the TI. It's either second, I think is what it is, or shift. You press that button, then you press the natural log button, and it should give you the e to the x. So what we're going to do is we're just going to type a few of these into the calculator. And then we're going to just write down what it says. It's pretty straightforward. I wish I had a calculator that I could bring up and show you, but you're really just typing it in. So for this, it would be 3 times. Then you're probably going to have to press the second or the shift button. Let me look for it on my calculator really quick. There it is. And then it'll give you either E with like a little box here, or it'll maybe give you, if you have an older calculator, it'll say E up caret parentheses. And then you'll put the exponent in the parentheses. So we'll put the 5 in. We're just going to have 3 times e to the power of 5. Hit enter, and then it'll give us a decimal. It's 445.239. And that's really all you're doing, is typing into a calculator and making sure you get the same thing. I would practice on these ones. Maybe open whatever calculator you're going to use, or open Desmos, and just make sure you know how to type them in. If you're having trouble typing them into Desmos, let me know and I can go over it with you. So if we type this one in, we're going to have 5 to the power of, 5 times e to the power of, I would type 0.5. I don't know that I'd try and do a fraction just because I think it's harder, but whatever you're comfortable with. And then we get 8.24361. And then your homework should tell you what to round to. It'll say round to 2 decimal places, round to 3 decimal places, round to the nearest tenths or hundredths or thousandths. Okay, 2 more. So we have negative 5.6 times e to the 3/4 or 0.75 power. And we get negative 11.8552. And then last one, 0.26 times e to the negative 4th power equals 0.004762. And there isn't really a way to do these by hand because you're doing an irrational decimal, e, to a power. You can't really multiply something irrational by hand, right? Because if you think about pi, 3.14, right, pi squared would be 3.14 times 3.14. And you could do this by hand, but it's wrong because these are rounded numbers. Pi is 3.1415926 something, right? It keeps going forever. So if you leave off all of these extra numbers, you're rounding and your answer isn't exactly correct. So if you anything you do by hand is going to be wrong. If you do it with a calculator, I think your calculator takes this to like 20 or 30 decimals and then does it, and then just gives you however many you ask for. So it's going to be better than whatever you do by hand until you get to calculus or whatever. All right. Couple more types of problems, or actually just one more type of problems. We're going to practice typing natural logs into our calculator. Most calculators now have an ln button. So instead of typing in the number first, you're going to type ln, and then it'll either give you a box, or I think on Texas Instruments, it'll say ln parenthesis. Then you type whatever you need inside your natural log and hit enter. So if we look at these, ln of 85, you just hit your ln button, you type in 85, and you hit enter, and it will tell you a decimal. For this one, it is 4.44265. And then these are really just typing into the calculator. There's not any like trick to it. You just type it in, and then you just write the answer to however many decimals your calculator gives you, or however many decimals the problem asks you to write it to. They're super straightforward. I'm definitely not just talking to fill time while I type these into a calculator, but they should be pretty easy. If you're getting stuck with these or you're finding these challenging, you're probably doing something wrong, and you should ask me for help. But you know, I'm not your mom and I can't tell you what to do. So try it on your own, of course, but they should be pretty straightforward for you. There you go. And those are your problems. Cool. Unfortunately for you, we have word problems. So now that we know how calculators work, right? Now that you've practiced a couple, I hope, let's do some word problems. So we're going to do 2. We're going to do that one and then this one. So it says the air pressure, P. So P is air pressure in this problem. Let me get a slightly more visible color. Is red more visible? Yeah, red's more visible. So air pressure is P. At sea level is 14.7 pounds per square inch. As the altitude H, so H is altitude, in feet above sea level increases, the air pressure decreases. The relationship between air pressure and altitude can be modeled by this equation. So the air pressure equals 14.7 e to the negative 4 zeros, and then a 4, times h. The Himalayas rise to a height of 15,275 feet above sea level. What's the air pressure at the peak of the Himalayas? The Himalayas, this is Mount Everest. So the highest mountain on Earth. So all they want you to do for these word problems in this lesson is plug numbers in and then use your calculator. So we are looking for what is air pressure. So P is going to stay a variable for us. Equals 14.7 E to the power of negative 0.123. Whoops. Oh no. Negative 0.1234 times H. And H is our height, which would be 15,275. When you type this into your calculator, I would multiply these two parts of your exponent first. So we have negative 0.12344 times 15,275. And these two numbers simplify to negative 0.611. Then, in your calculator, I would do e to the negative 0.611. As I type that in, 0.611. And then I would take that number that I just got, 14.7, times 0.542808, and then multiply these. The reason I would do this as multiply the exponent together, simplify the e, then multiply the numbers, just so we have an answer. P equals 7.979 pounds per square, per square inch. The reason I would do these separately is because if you try and type this whole thing into a calculator, a lot of times you're not sure what the order of operation that a calculator does is, and it will mess it up, and then you'll get the wrong answer, and you'll have no idea why. If you do it one step at a time, you have a little bit more control about the order of operation, and it just makes it easier for you to understand what goes wrong and where. So I recommend doing it step by step. Let's look at one more problem. The area of a wound, so if you like scrape your knee, the size of that scrape, the area of the wound decreases exponentially with time. The area A, so this is how big the wound is, A. Pardon me, sorry, I had to sneeze. Of a wound after T days, so T is our time in days, can be modeled by this thing here. This is the equation. Where A subscript 0, this would be said as A naught. Not naughty, like a puppy, right? Not, as in like the European word for none, 0, right? Where A naught is the initial wound area. So this is how big it is at the start, initial. If the initial wound area is 8 square centimeters, how much of the wound would be present after 6 days? So this will be T. Let me get a better color. So this is A naught, or our initial size is 8 square centimeters. Our time equals 6 days. And we're just going to plug these two numbers into this. And then we're going to simplify. So the size of our wound equals the initial size, which is 6, times e to the negative 0.05 times t, which is 8. So again, I'm going to multiply the two numbers in the exponent together first. 0.05 times 8. I get negative 0.4. So we have a equals 6, e to the negative 0.4. Then I'm going to do the e to the exponent. And I get 6 times 0.67032. And then you just multiply these in your calculator. And we get A equals 4.022 centimeters squared. Or square centimeters, same idea. So that's how big your boo-boo is after 6 days. Cool. All right. So that is your notes. If you have any questions, please let me know. Please actually try and type some stuff into your calculator as I'm going along with this. That way you can just make sure you're typing it correctly. And we can find out now before you get a 0 on your homework and you get frustrated and you don't want to do it again. So let me know if you need help. If not, make sure you like and subscribe. Have a great day.